Hello everyone, in this video let's take a quick look at sets in Python. So a set is an unordered collection of unique items. So the order of the items within the set actually doesn't matter, and you shouldn't assume that it's always going to be the same when you iterate over the set. And likewise, you could have the same thing show up multiple times in a set, but they're unique. So basically, you'll only have it appear once in the final set, once that line has been evaluated by the interpreter. So let's actually assign this set to a variable a, and we'll check if something actually exists within this set by saying 1 in a. So 1 is in the set a, so therefore it returns true. Likewise, if I say 0 in a, this returns false. You could also say 0 not in a. You could make it sort of do some conditional. Yes, that needs an if. If 0 not in a, then print something, and that would say something. So this is how you check if something actually is within a set or not. We can also check if a set is a superset of another set, or if a set is a subset of another set. So let's begin with the set we had initially, 1, 2, and 3. And this is how you would check if a set is a superset of another one. So set, and this one would contain 1, 2, and 3 as well. And this returns true because a set is a superset of itself. And a set is also a subset of itself. So is 1, 2, 3, 4 a superset of 1, 2, 3? And yes, it is. Is it a subset? And no, it isn't. And likewise, we can check it the other way, just to really be explicit. Is 1, 2, 3 a subset of 1, 2, 3, 4? Well, yes, it is. And is it a subset of 1, 2, 3, 4? And no, it isn't. Now let's take a look at some operations on sets. Let's check the difference of these two sets, and this is actually the intersection of the two sets, right? So the intersection of the two sets represents the items that are in both sets. The union of both sets is simply what happens when you add both sets together, and once again the items are unique, so they'll only show up once. And we can also have the symmetric difference of two sets, and the symmetric difference really just represents items that are not in both sets. So for example, if I add 0 here, then the symmetric difference is 0 and 4, because items 1, 2, and 3 were in both sets, whereas item 0 was in only one of them, item 4 was in only one of them as well. You can also perform the same 3 operations while assigning the result to one of the sets that's being operated on. So let's have set A equals what we had earlier, so 1, 2, and 3. And let's have the intersection with the equals operator of the second set, which shall contain 2, 3, and 4. And A is now equals to 2 and 3, because that's the intersection of these two sets, but the result has now been assigned to set A. Let's declare set A again as 1, 2, 3, and this time we'll do it with the union. So A is now the union of set A and set B. Let's recreate our set A as it was earlier, and we can have the same thing again, just for being really thorough and explicit, for the symmetric difference of the two sets. Finally, I mean, this pretty much covers a lot of the functionality of sets. What we can also see is, because we haven't done it, is to actually iterate over a set. So for item in A, print item. This simply iterates over the elements of the set. Once again, you should not assume what the order of that iteration is going to be. And this pretty much covers sets in Python for now. So thank you very much for your attention, and I'll see you in our next video.